Today, I will walk through Actian Data Observability from the data platform engineering perspective. We'll explore how you detect data reliability issues early and decide whether your data is trustworthy or not, understand the impact of those early detection issues, as well as root cause them quickly. And one of the more important aspects we'll explore is how to operate reliably as data volume and complexity scale. We'll start with how Actian surfaces issues through automated Slack alerts and ties them directly to platform health and incident status. Then we'll look at how trends, investigation workflows, and adaptive monitors help reduce repeated incidents and the time spent on comprehensive root cause analysis. We'll then close with how the MCP server integrates observability context into your daily workflow to accelerate understanding and resolution. I want to start where data issues usually show up for engineers, and that starts with a notification in a messaging platform such as Slack. The alert that we're looking at here, for example, represents some kind of an interruption. Something changed, perhaps someone may be blocked, and now engineering attention is required. Alerts are routed to the right owners instead of blasting the entire organization, and they are correlated across multiple signals so engineers can quickly understand what's actually happening and where to focus. In our example here, an out-of-the-box Actian Data Quality Monitor has detected PII exposure. It detected that exposure within a particular asset, in this case, a raw customer table, and specifically calling out the attribute field it was exposed in. Both the detection time and severity levels are called out as well. And zooming in here to the chart, we have plots of observed, predicted, and in this case, since we're monitoring PII, we predict that there shouldn't be any exposure to that, as well as anomalous behavior. And we can infer the trending of this behavior just by looking at the graph itself. The value here is that Actian early detection reduces stakeholder-driven escalations, which as a data engineer or any other data expert, we definitely do not want it to ever come to that. But also it shortens time to awareness for the engineer. Some things to think about when and how you're being alerted to data issues. How often do you learn about data issues after they've already impacted someone? What usually tells you an alert is real versus something you can safely ignore? Now, once an alert fires, the next step is understanding whether this is an isolated issue or something affecting overall platform health. The overview page gives engineers an objective snapshot of the platform health. So instead of relying upon anecdotes or random Slack threads, you see the current total number of incidents across your entire observed and monitored data estate. You also have an immediate understanding of the mean time to resolve those incidents, tag distribution, severity level, scope of those incidents in terms of the affected assets, all of this in one place. A few more things to call out. Not only is the incident status and severity level clearly marked, but at a glance, you can see whether an incident is still active and being worked on and open versus a resolved closed issue. So you are provided clear prioritization signals, providing direction and granular starting points. Really, the value call out here is that by detecting issues before data ever reaches downstream systems, Actian reduces cascading failures and extended data downtime. Other thoughts to consider in terms of observing your entire data estate are How early in the pipeline do you typically detect data issues today? Is it before they hit the warehouse, or is it after downstream systems start breaking? When those issues are detected, how confident are you that you're seeing the root cause versus a downstream symptom? So what you're seeing here is a single real-time view of platform health, active incidents, their severity and scope, detected as far upstream as in object storage and across all data types. So issues are identified at the true source before they cascade downstream. Seeing current health is critical, but the next question for engineers is whether these issues are isolated or part of a recurring pattern. This is where trends and alerts make clear for us over time. Trends show where engineering time is being drained. The view makes it clear whether issues are isolated or more systemic. Trends reveal whether issues are isolated or recurring across data sets and time. So instead of reacting to individual alerts, the data quality indicator shows whether overall data health is improving or deteriorating, thus helping engineers prioritize systemic fixes. This view provides a clear signal of platform stability over time, supporting better prioritization and operational planning. Once we know an issue is real and recurring, the next step is really understanding exactly what changed. And the investigator is the interactive workspace engineers use to explore, diagnose, and resolve data observability issues once anomalies are detected. The investigator provides a granular view of your data at both the attribute and record levels. Users can compare compressed and expanded patterns to pinpoint where and how data deviates from business rules. The investigator provides full contextual exploration, allowing you to drill down into data characteristics, including its metadata, distributions, trends, and attribute level statistics, really making it easy to compare good versus bad data and understand how behavior has changed. Some of the other things to make note of are the deep descriptions providing you an understanding of various outlier factors. All of the records with this particular value and other attribute level statistics, thus giving you the means for traceability. So instead of writing ad hoc SQL, digging through logs, or coordinating across various tools, engineers get a single shared workspace for diagnosing, explaining, and fixing data issues. And to make things even simpler, since the data engineer's primary pain is both figuring out what went wrong and how to fix it, that latter one being a high-value, non-trivial task, but by leveraging the Ask AI feature to outline and draft potential remediation steps. This provides a shortcut for soup to nuts root cause analysis, remediation, and even downstream impact. In this particular example, we simply asked for remediation steps. Now, this is contextually focused in the investigator page, and the result is that either data binning or circuit breaking or a combination of both, can be used to separate valid data from problematic data and switch off ETL when that bad data comes in at the source. Some thoughts to consider. When an issue is flagged, how do you typically figure out which fields or records are actually causing the problem? How do you determine whether a data issue is isolated to a few records or widespread across the data set? Together, trends and alerts show which issues are recurring and how widespread they are, while the investigator provides the granular evidence engineers need to quickly pinpoint root cause and understand the blast radius. Once you can clearly see which issues matter and exactly where they originate, the next step is preventing them from happening again, which is where the monitoring comes in. Once engineers understand where issues originate and how widespread they are, the next step is preventing those issues from recurring. Actian continuously monitors for the most common and most disruptive data failures with 16 out-of-the-box machine learning-driven monitors. Here you can see those outlined at the bottom with the blue shield icon. Our monitoring expert in a box automatically looks for things like freshness, structural schema changes, different volume anomalies, data differences across your systems, drift in its different forms, correctness, and business critical metrics. Other notable mentions: Actian automatically applies these 16 monitors to your assets on the very first scan. This way, engineers don't start from a blank slate or have to anticipate every failure mode. And this, by the way, is a full table scan, not just a sampling of your data, because the full picture is often missed. Instead of requiring engineers to write and maintain custom rules, these monitors learn patterns directly from the data, their normal distributions, their relationships and trends, and then continuously evaluate incoming data in batch or near real time. Monitoring rules, full functionality is available and provided as expected. Maybe this becomes obvious, but really the value here is that this replaces that reactive ad hoc rule writing with a single standardized view of monitoring across the platform. Some things to consider: how much of your monitoring today is proactive versus checks you end up adding only after an incident has already happened. Monitoring shifts from a collection of one-off checks to a consistent automated signal that scales with the platform and evolves as the data changes. With reliable detection in place, the remaining challenge is quickly turning signals into a shared understanding and action, which is where the MCP server helps. The MCP server embeds observability context directly into the engineer's daily workflow. Faster understanding, fewer context switches, and cleaner handoffs during incident response. As an example, we can feed it simple prompts such as, hey, what are the top recurring issues impacting platform reliability this week? Or something a little more complex, such as, stack rank the top 10 sources, their associated tables that have the highest exposure to PII. Tell me what type it is, which columns or fields it appears in, and provide that result. As you can see, in this case, I prefer Claude with my MCP server, but we get back rich contextual responses direct from the data in the platform. So instead of manually reviewing alerts or dashboards, engineers get a prioritized view of what's actually degrading reliability. This way they can focus on fixes that reduce future incidents. So in the last 15 minutes, we showed how Actian helps data platform engineers detect issues early, improve platform reliability, identify systemic problems, accelerate root cause analysis, scale monitoring without scaling the team, and accelerate understanding with MCP in the flow of work. Thank you.